Hello everyone. In this video, I'll be guiding you through the process of creating your own AI cover. We'll cover everything from the necessary requirements and tools selection to selecting the right data for training your AI model. I'll provide a training tutorial to assist you. And we'll also explore how to apply voice modifications. Let's get started. In the first step, I'll walk you through the requirements for creating an AI cover. The most crucial requirement is an NVIDIA GPU. While it doesn't necessarily need to be a high-end GPU, having an NVIDIA GPU with a minimum of 6 GB of VRAM should suffice. If you don't have an NVIDIA GPU, don't worry just yet, as there are still options to access free GPU computation power on the internet. One such option is Google's Colab, which provides free GPU resources. However, the tutorial for using Google Colab is beyond the scope of this video. If there is enough demand, I'll create another video specifically addressing how to create an AI cover using Google Colab. The second requirement is a digital audio workstation, commonly referred to as DAW. A DAW is essential for editing the audio files, a crucial step in creating an AI cover. While some DAWs may seem expensive at first glance, many of them offer monthly rental plans that are more affordable. Additionally, some DAWs even provide free trial periods, allowing you to test them out without any financial concerns. So, there's no need to worry about the cost. The final requirement is the actual audio tracks we will be using. Ideally, we need both an instrumental track and a vocals-only track of the song. If you can find the official instrumental and vocals-only tracks, that's fantastic. However, in many cases, official tracks with separated vocals and instrumental may not be available. In such instances, we will require vocal separation software. Fortunately, there are numerous free vocal separation software options available on the internet, as well as some paid alternatives. While the paid software may come with a price tag, they often offer better performance in most cases. Speaking of vocal separation software selection, there is a free option called Ultimate Vocal Remover, along with several other free alternatives available on the internet. If one software doesn't work well for you, it's advisable to try different options until you find a satisfactory solution. In terms of paid software, one of the most popular choices is SpectraLayers Pro. Once you have gathered all the necessary components, you can proceed with installing the AI tools required for creating AI covers. The software you'll be using is an open-source program called SoftVC Singing Voice Conversion Fork, available on GitHub. A quick Google search will lead you to the GitHub page where you can find the software. On the GitHub page, you'll even find a convenient one-click installation file. Simply download the .bat file and execute it to begin the installation process. When installing, click on More Info and select Run Anyway to initiate the installation process. Please note that the installation may take some time to complete, so we kindly ask for your patience. To enable the execution of the AI tool through the command line interface, follow these steps to add the tool's path to the environment variables. Open the File Manager and navigate to the desired location. Click on View and select Show Hidden Files to ensure visibility of all files. Access the following path: Disk C, your username, app data, roaming Sovets SVC fork, vent, scripts. Click on the directory icon and copy the path. Search for View Advanced System Settings in the Windows search bar. Click on the corresponding result to open the Advanced System Settings. In the Advanced System Settings window, select Environment Variables. Find the path variable under the System Variables section and double-click on it. In the new window, click on New and paste the previously copied path. Click on All OK to save the changes. Close all System Settings windows. With these steps, you have completed the installation process for the AI tool and added its path to the environment variables. To verify the successful installation of the AI tool, follow these steps. Right-click on the Windows Start icon. From the context menu, select either Terminal or Windows PowerShell. Type SVCG and press Enter. After a few seconds, a graphical user interface of the software should appear. The appearance of the graphical user interface confirms the successful installation of the AI tool. Of the AI tool by launching it from the Windows Start menu. Now, let's proceed to the dataset collection phase. Our dataset consists of vocals-only tracks for the singer we want to imitate. If the singer is popular enough, there might be a cappella tracks available on the internet. If not, you will need to use vocal separation tools to extract the vocals from existing tracks. Once we have obtained the vocals-only track, there are certain conditional restrictions to consider for our dataset. These include ensuring that the vocals are approximately 10 seconds in length, contain only one vocalist, approximately 10 seconds in length, contain only one vocalist, and preferably have no harmony parts. To meet these restrictions, we will need to edit the vocals-only track using a digital audio workstation, DAW. I personally use Cubase 12, but any DAW should suffice. If you encounter any difficulties while using your DAW, you may need to search for information online as it goes beyond the scope of this video. During the dataset collection phase, I personally prefer to classify the vocal tracks into different categories. These categories include regular singing, distorted singing, and screaming. However, you can explore and experiment with different classification methods to observe their effectiveness. Feel free to try out various approaches and assess their performance. Once the dataset collection is complete, we can proceed to train the AI models. To initialize the training process, you can easily obtain the necessary files by downloading the zip file from the Sovitz SVC Fork GitHub page. After downloading, extract the zip file and locate the tests directory. Copy and paste this directory to the desired location. Next, remove the raw dataset from the dataset_raw directory and replace it with our singers dataset. Which should be placed in the dataset_raw/speaker_id directory. To initialize the training process after placing the dataset, follow these steps. Right-click on the Windows Start icon and select either Terminal or Windows PowerShell. In the Terminal window, type cd directory /to/your/working/space and replace directory /to/your/working/space with the actual path of your working directory. You can copy and paste the path from the file manager. Once you have changed the directory, type svc pre-resample in the terminal and wait for a few seconds. This command will resample the data. After the resampling process is complete, type svc preconfig in the terminal and wait for a few seconds. This command will perform preconfiguration tasks. Next, type svc pre-Hubert in the terminal and wait for a few seconds. This command prepares the Hubert model for training. Finally, you are ready to configure and train your AI model. To initiate the training process, follow these steps. Open the terminal and type svc train nt if you are unfamiliar with reading information. In TensorBoard. If you are comfortable interpreting the information, you can use svc train t instead. If your terminal displays out-of-memory errors, you need to edit the config.json file to reduce VRAM usage. The config.json file is located in your working space, specifically the tests copy/configs/44k directory. Open the config.json file using Notepad or any preferred text editor. Locate the batch_size section in the config.json file and divide the original value by 2. For example, if the original value is 16, change it to 8, and save the file. Return to the terminal and type svc train nt again. Ensure that the terminal is in the directory of the Singer model. If it is not, use the cd directory /to/your/work/space command to navigate to your working space directory. If you still encounter out-of-memory errors after executing svc train nt, reduce the batch size value further in the config.json file. For instance, if the current value is 8, change it to 4, and save the file. Repeat the process of modifying the config.json file and configuring it until you can initiate the training process without encountering any errors. By following these steps, you can adjust the batch size in the config.json file to address VRAM issues and successfully start the training process. Once the training process has started successfully, it will display the current training epoch and save the AI model after a specific epoch. At this point, you can leave the computer and allow it to continue the training. It is recommended to train for a minimum of 1000 epochs. If you haven't modified the epochs value in the config.json file, the process will automatically stop at 10,000 epochs. During the training, you have the option to perform AI inference tests at intervals of every 1000 epochs to evaluate the quality of the generated results. I will now guide you through the steps to perform AI inference. Typically, training for several thousand epochs should yield satisfactory results. To perform inference, follow these steps. Open the terminal or Windows PowerShell. Type SVCG into the terminal, press Enter, and wait a few seconds for the graphical user interface to appear. In the graphical user interface, select the AI model and locate the config.json file. Adjust the pitch value to 0 and change the F0 prediction method to CRAPE for improved pitch prediction. Make sure to turn off Auto Predict F0 as it can cause pitch instability. Select the vocals only track and disable autoplay while adjusting the presets. It may be necessary to add a preset and then select it for the settings to take effect, depending on your environment. Finally, click the Infer button and wait for the inference process to complete. By following these steps, you can successfully perform inference using the AI model and adjust the necessary settings for optimal results. After performing the inference, you should find a file named original_file_name.out.mp3 in the same directory as the vocal track. You can play this file to evaluate the generated output and assess its quality. If the results sound satisfactory, proceed to your digital audio workstation (DAW) and merge the generated vocals with the instrumental track. It's important to note that when the singer uses different vocal techniques, you may need to apply different AI models corresponding to those techniques. For example, if the singer performs regular singing or screams, you should consider using specific AI models tailored to those particular vocal styles. Finally, in your digital audio workstation (DAW), you can easily cut the generated vocal track and place it in its appropriate position within the composition. If you encounter any difficulties in your DAW, I recommend searching for solutions on the internet as it goes beyond the scope of this video. There are numerous online resources and forums available that can provide assistance specific to your DAW-related issues. That's it for today's video. Thanks for watching.